So in the last stream, that was Thursday, I've been working on a, well, started to work on a little tool called the GB Header Extractor. Very fancy name, I know. And essentially what I've been trying to do is, with the help of the um, Nintendo programming manual, where is it? Sorry, the Game Boy programming manual right here, and the GB Dev Pandocs, to basically figure out what is stored in the header of every ROM from a Game Boy cartridge and read out that information and make some sense out of it, right? Uh, Tool was very crude. It was just well, let me just show you how about that in case you haven't been in the last stream. Um, so here we are. So basically, I have two ROM files here, right? Tetris and Super Mario Land 2, both of which I own as actual cartridges. And I basically hard-coded the path in here, opened the files, read them out, right? We read out a 4 kilobyte chunk of data, and then started reading out the header. As you can see, that we have specified all these different locations here. We have just directly read out the information, passed it out, and then printed it out onto the screen. So if I run this now, for example, with the Tetris ROM, you get all this information. So the title, the game code, which is non-existent because it's an old cartridge. We have the Game Boy Color mode, which again, not existent because it's an old title. We have the maker, which is Nintendo. We have a Super Game Boy mode, which again doesn't exist because this game is older than the Super Game Boy. We have the cartridge type, which is a ROM only, the ROM size, extra RAM size, and the intended market destination. Yeah, and then the cartridge version. So we can do the same thing now with the. I do not have my keyboard enabled. Hang on. Yeah. We can do the same thing with the Super Mario Land 2 ROM. And we get similar information here, except obviously a different title, Mario Land 2, and we have a different cartridge type, because this one has actually ROM and an extra battery. The ROM size is 512 kip, and the extra RAM size is 8 kip, right? And the market is worldwide. And it is version 2 of this particular cartridge, which I thought was interesting. So, but this is a very crude tool, right? I would like to refine this a little bit. So what I would like to do, and I made a little to-do list for this, so let's write all this down, right? So what I want to do is I want to specify an input path, and then read out every ROM within that path, right? Then I want to specify an output file, write every ROM header info into that file. It will be CVS formatted. Sorry, CSV formatted. So CSV stands for comma separated values, which basically just means, you know, you have one value, you have a comma, another value, comma, another value, right? And then some tools like Excel, for example, can display that as a nice table. I also want to be able to go through the input part recursively, so if there are any subfolders, it should go through those as well. Excuse me. I hope that doesn't happen too often. And there's a few other things I like to add, but those are very specific command line flags, which I will go through once I actually reach that, that particular area of interest. For example, I want to be able to disable writing the header, and instead of writing to the output file, actually just use piping. For console application, piping is sometimes useful if you want to take the output of one console application and pipe it into another, which I think could be useful for some instances, but I don't know yet. We'll see when we get to it. So the first logical thing to do, I think, would be to take all these things and try and put them in a struct. Right, so we can easily pass it around the program. Okay, let's just make a struct of this thing. So we have all this information here, right? So copy that here for easy access. And we can just say type dev struct, make it just header struct, and this is a header t. We can name it GB Header actually. Why not? Okay, what information do we want? So entry point, I'm not sure if we're particularly interested in that at all. Nintendo logo, let's leave it out for now. One interesting thing would be the game title, I suppose. So this is char title. And the title can actually vary, so it could either be 16 or 15 bytes. Hang on, title. So it could either be 16 characters or 15 or 11. Okay, we can assume that the title is usually 16 bytes long. However, if we have one of these flags, so Game Boy Color flags, we know it is a Game Boy Color game. So which then could mean it is actually 15 bytes long, because we're ignoring this byte. But how would we determine if it is newer than that? I mean, if it belongs to the title, fair enough. I think I'll just split it up for now anyways, and just assume the game title to be bytes all the time. How do we get on about this? How do we feel about this? Let's just do 16. Let's just assume it's always 16, right? Then we have the code, which is F012, so that is 4 bytes. That's the game code. This, we got this, Game Boy Color support. Actually, I don't want to make this a flag. Let's make this an enum. GB Color support. right. Let's make it the type def instead. So, we have monochrome only, which we can set to null. Then we have color compatible, and we have color only. Right. Actually, color support none. Let's make it this way. It's just a bit nicer to name it the same thing. Compatible and exclusive. That sounds better. Okay. So we have the color support. We have the maker code, which is. We have to see about that one. Make a code here. We have. Let's just leave that one out for now. Then we have the Super Game Boy support code. Naming. I hate naming things. It's my biggest struggle. So we either have no Game Boy Super support, Super Game Boy support, or we have it. Available. Enabled or disabled. I think that's all right. Okay, so we have game title, we have game code, we have the Game Boy Color support. We do not have maker code yet. That's the one missing, right? Let's copy these to the specific locations. That will help me later on. Okay. Do not need the flags anymore. Okay, cartridge type. I mean, I can prepare an enum for that as well because those are rather fixed as well. type the venum GB cartridge type. Let's call it pack type because that's what it's called in the manual. They define it as pack. Pack type, and we have unknown. Right. Well, no, we get to unknown in a bit. I wonder if that can be anything else. This will always default to none because it can be anything else, but that is just part of the title. Okay. Pack types. We have a list down here. So I guess we can just copy these. Right. And associate them with the same numbers. Actually, Moby should have done that with... Nah, with these it doesn't make sense. Okay, whatever. Okay. So we have ROM only. ROM only, which is this one. Then we have MBC1. Right. We have MBC1 RAM. MBC1 RAM battery. We have MBC2. MBC2 and battery. We have ROM and RAM. We have ROM, RAM, and battery. We have MMM01, whatever that is. We have MMM01 RAM. MMM01 RAM and battery. That's a bit of a tedious part of typing that out, but memory bank controller 3 with a timer and a battery. Right. Then we have memory bank controller 3 with a timer, with RAM, and with battery. We have memory bank controller 3. We have memory bank controller 3 with RAM. Memory bank controller 3 with RAM and battery. Memory bank controller 5. I do not know what these all the different memory bank controllers are yet and how they work, but we'll figure that out once we get to actually programming stuff for this, for the Game Boy, I mean. For now, just memory bank controller 5, RAM and battery. MBC 5 and rumble. And then we have actually as I'm typing all this out I'm wondering if I shouldn't do it as like some sort of flags or something. You know, instead of having like these specific enums, doing something like, oh, does this pack have RAM? Yes or no. Then have another flag for, does this thing have a battery? Yes or no. But I mean, they have very specific codes, so maybe not the best. Let's keep it like this. I feel like the other way around would be overcomplicating it, really. Rumble, RAM, and battery. MBC 6. MBC 7. Sensor. Rumble, RAM, battery. Camera. Bandai Tama 5. HUC 3. And this is HUC 1 with RAM and battery. Okay, GB pack type T. call. Pack type. Okay. I'm now wondering if it would be worthwhile storing like the unknown byte value that I get in there as well to print it out into the table in the end. Not sure. Let's leave it like that for now, whatever. So then we have ROM size and RAM size, and I feel like I should make this an enum as well, because there's like fixed values, right? So we have this for ROM sizes. Yeah, let's take this. Okay. GB ROM size. I should learn how to type. GB ROM size T. And we have these. Yeah, let's leave it like that, whatever. Whoop, nope. I wanted this. 64 kib. And then we have 128 kib. Cool. Whoa. Jesus Christ. I'm all warmed up. 256 kib. Hey Kakalak Joe, you didn't miss much, honestly. So what I'm trying to do at the moment, just to recap, I suppose, is this was a very crude program that just printed out the values in the console application, and then I want to reformat this to be, you know, slightly more useful, as in you specify an input path and it just grabs all the files there and prints it all out into a nice Excel file, or a comma separated value file at least. And to just make the code a bit nicer, I'm gonna make this GB Header struct type that kind of takes all these different things and puts it all into one type so it's easier to access. So yeah, basically just reformatting my code a little bit. Right. Okay, then we have one mib. Yeah. Kind of like it with an underscore at the end here. It's a bit nicer. Actually, how about that? This is 2048. Yep. 2 meg. then we have 4096 kib is 4 MIPS. And then we have maths. How do you do it? Embarrassing, I know. Almost. This should be a 9. Okay. This is 8 MIPS. Can we have different values in there? I mean, in theory, yes. So what we should probably do is unknown, right? In case we have anything other than these values right here. So this is ROM size. GB ROM size. And then we have RAM size. So GB RAM size T will be RAM size. Cool. And that will be type def enum GB RAM size, and we call it GB RAM size T. Cool. So which values do we have here? Gotcha. Just these. What was I? There. Okay. So we have none, no ROM whatsoever. We have a kib, right? We have 32 kibs. And we have 128 kib. Cool. And it can also have an unknown. Right. ROM version is just a byte, right? So we can add that. That is fine. So that will be a U8. And just call it version. Destination code, I mean, that's fairly simple, right? That's just 2 values from what I remember. Type def enum GB destination. So destination, what do we have? Just 2 cases, Japan or worldwide. I love this. Okay, so we have GB destination Japan, which we learned can also mean worldwide. Worldwide. Oh, Jesus. GB destination worldwide, which means worldwide but excluding Japan. So, and destination can be unknown as well, because there could be some different codes in there, right? Okay, destination code. We have that right here. So GB destination. Let's call it destination. Cool. Right. Actually, no longer need this here, do we? Okay, so I guess the first thing to do would be try and read it out and put all the values inside our new struct that we have, just to make sure everything works as intended, right? So let's do that. We have a GB header, call it header. Do we need to initialize it? Fuck it, no, we don't need to. Okay. Let's start with the title. So we separated title and game code. I guess the first thing we want to check is the Game Boy Color support code, because it overlaps with the 16-byte title, right? So if we have any of these values, we know the title is only 15 bytes, not 16. Okay, so let's do a size t. Let's call it title size, and we set it to 16, right? But we check in our buffer, we check the Game Boy Color support code first. Actually, let's make it a switch. I lost my train of thought, I apologize. Right, Game Boy Color support code should be one of these. Why did I not make this the same? Well, it should be like this. Okay. Header, color support, geez, dang it, okay. And we set it to color support compatible. And then we have this case, where it is an exclusive. Header color support is this, and otherwise it's header color support none. Okay, title size we decrement here, because if it's either one of these codes, then the title is only 15 bytes long, because you're using the last byte as an indication of the Game Boy Color support. Okay. And I realized I probably need to make this 17 because I need to account for the null character. Okay, so we have title size 16. If it is any of these Game Boy Color support things, the title size is only 15. And I have not yet determined when title size is actually just 12. But given that the next 11. But given that the next bytes are the maker code anyways, so we know they will be in a valid ASCII range, so we can just include them as well. Doesn't really matter, to be honest. I think, at least. And if we use the same string copy anyways, it will stop on a null character. So there either will be a nice separation between oh, excuse me. I'm still slightly sick, I'm sorry. So you'll hear me cough a little bit. Okay, so we will either have a title with a null separator and not the game code included, or if the title is long enough to actually fill all those 11 bytes without the null termination, then our title will include the game code as well. So what we want to do now is string numbered copy, right? And we want to copy the data from the header into the title section of our header struct. Should probably use the safe version that Microsoft recommends to use, which is, you know, not portable, but whatever. So the size in bytes of that particular buffer, well, I specified it as 17, right? So it is 17. The source will be the buffer, and as before will be that location in memory. So the buffer starts at 0, 0, location 0 of the ROM, right? And we just want to advance it to that particular position where we know that the title starts, as defined in the manual. And the amount of characters we actually want to copy is title size, right? Which again, this might include the game code, so we should maybe let's make a to-do here for us for later, because there surely must be a way to figure out whether a cartridge is new enough that it includes a game code or not. Right. Okay. And then we can also do the game code with strn copy as well. We go to header code. The code is 5 long, right? I did make it 5. Yep. And we have buffer plus this location in memory. And the size is actually just 4. Okay. So now we copied this in our header struct. And what we can do is just print those out. And then let's see if it works. And it still works. We have title, Mario Land 2, and the game code is just 0 because I don't have a new cartridge at all. Now we can do the same thing with all the other stuff. So we have set the Game Boy color support, we have the title and the code, and now we can continue with all the other things. I guess we can already print out whether it's Game Boy Color compatible or not, right? So printing code, and here we have the reading code, so we can actually nicely separate this. Unfortunately, we have to switch over the color support and then just basically say if it is compatible or if it is exclusive or if it is basically none. Let's make it this way. Color support, we have color support is compatible. And color support exclusive. And then default would be just none, I suppose. Yeah, no, let's just do it none. Okay. And then we can say printf. Again, color support is this one. Okay, Game Boy Color support. Whoops. Right. Should have added a new line and deleted the old printing. Okay. There we go. Game Boy Color support. None. Perfect. Okay, I didn't do anything with the maker stuff yet, but we have the Super Game Boy modes, which we can print out. Okay. So Super Game Boy support is either disabled or enabled or unknown. Let's make this the same number actually. wonder if unknown is actually needed. I could just say disabled. Yeah, let's just do that. Makes it easier. Basically, only if we have this value, Super Game Boy is supported. Otherwise, we just report it as not supported. Which makes this relatively easy because we can just say switch buffer, right, and it's application. Actually, let's just do that. And then we have super support is this. Otherwise, okay. Now we can adjust our printing to super support. Right. And voila. It works. Okay. So we have color support, we have super support, and now we should do pack type and ROM and RAM size. Okay, so pack type we named cartridge type, which the printing code will probably more or less the same, except we will be printing out header pack type. And I could adjust all these values to be the enum stuff, but I won't do that for now. Because this code is just testing, right? It won't survive until I write out into CVS anyway, so let's just ignore that for now. Okay. So, what are we doing? We are doing this. There's some values missing here and there. That's too bad. I was hoping I could make this like really easy. Oh well. Okay, and we have header pack type. I wonder if I should just cast it. You know what? That's actually a better idea. Because then in the printing, if it is none of these values, I can just say it's something unknown, right? It's probably way better. Okay, let's do that. I should have done this with the other fields as well. Oh well. Once I take it out and put it in a separate function, I can do that, I suppose. Whatever. So we have header pack type, header pack type. So if we do this, still works. Fantastic. Cool. Yeah, so I basically can do the same thing for ROM sizes, RAM sizes. I can remove the unknown here as well. Okay, so okay, ROM size will be header ROM size. And then we can do here. And this will be 149. Whoops. Okay, and then we have a destination. Where was I? There. Okay. And then we also have version, which will be header version. Okay, cool. So that all works. I have been ignoring the maker codes because those are quite extensive. I'm still not sure what the best way is to do those. Because there's also two different maker codes, right? There's the old maker code and the new maker code. I mean, an enum with all of these names would be quite good, I think. Oh, you're right. I did have a typo. Super Game Boy. Okay. Good catch. Thank you. Let's just do it as a string. I think that is the easiest thing to do. So let's call it maker, and what we're doing is, and let's just say we support 24 characters, so let's do 25 for the null separation. Yeah, why not? So, and the maker code is a bit more interesting, right? There is this whole stuff involved with it. Okay, so what we can do is the printing of maker will just be this. So we're just printing out the string of the header. Actually, let's move this right after the game code. So this is our printing code, and then we have the reading side of things. So this is quite quite extensive. Yeah. Okay, let's just copy that up there. Where do we want to put it? Let's put it at the end for now. It's probably easier to remember. Sorry, I'm just thinking of what the stupidest way to do this would be. I think I pretty much won't touch this at all. We have the maker here, and what I'm just going to do is just copy it into the right location, right? So header maker, we said it's 25 bytes. We're getting that from maker, and the maximum count we have will be 25 as well. Okay. There we go. Cool. Okay. Actually, let's copy this here. Do I have the old maker code somewhere? I called it old license code. So it's either this or this. So there's a few other things left, like the entry point, the Nintendo logo, the complements check number, and the checksum of the entire ROM. But for now, I'm just going to ignore those. Do not care about those at all. What would be nice now, instead of having, these hard-coded paths here, would be to be able to specify a folder, or rather, if there's no folder specified, let's start that way. Yeah, sorry. Let's just start out with getting the current folder the executable is run from, and just try and fetch all the files from there, right? And I'm going to steal some code that I've written previously on my static website generator, because there's similar things done already. Yep, let's just copy all of this stuff. So this is just, I don't think we will use this. Basically what I'm doing is I'm including the Windows header, because I'm using some Windows API functions now to do certain things, especially like iterating through folders. And all of these defines here are basically a way of excluding some things of the Windows header that we know we won't be using, right? So we don't use any GDI stuff, we don't use any kernel methods or anything like that, right? We don't have kanji support, we don't need the help API, all this kind of stuff. So you can basically just disable that with all these defines. There's a lot of them. It's also a bit hard to figure out what disables what. Those things are not entirely well documented, but you can basically find them when you look into Windows header. There's some of those here. Some of the other values I have found on some websites that were suggesting different things, right? So, but yeah, this is basically a way to control what you're importing from the Windows header. Right, we're not going to bother with a different folder for these, like a different include file, I mean. Let's just leave it like this. I know it gets a bit clunky at the moment, but we can refactor all this later. Okay. So to get the current working directory, we have get current directory right here. And I'm going to steal this print Windows error method as well. So basically any Windows API that you call can return an error code, right, if it's not successful. And to get the last error message, what you then have to do is call get last error, which returns your D word, and then you have this format message where you then, ask Windows to give you the actual error message formatted in your current locale, and it's also allocating the right amount of memory for the message itself. So then you can print it out into standard error if you would like to, and then just free the message buffer in the end. Excuse me, I need to drink some more water. Still slightly sick, which is annoying. Okay, so let's just copy this print Windows error stuff down here. In case you're wondering what these are, this is basically the same way printf is done in C, right? This just means you can pass in any number of arguments, and these are stored in a VA list, which you then can, cobble together in like your output buffer that you have here with, excuse me, with a specific printf function that is able to operate on these arguments. Yeah, it's kind of nifty. It's basically what allows me to do here is just call print Windows error and put in some arguments as I would like with printf to have some nicer error messages, basically. Okay, so we have print Windows error. We need the definition up there because this is C after all. Let's just plonk this in here. Okay, and then what I wanted to copy was, let's put this here on the side. Yes, this one. So this will get the current working directory. We have an input path buffer, which is 260 characters wide, although this code is no longer quite correct because, so get current directory is just a macro that calls one of these two versions here, either get current directory W or get current directory A. A is basically the ASCII version, so uses just 1 byte for a character. And W stands for wide, which is using wide characters, which Windows is using internally for every strings. So Windows uses 2 bytes for a character, basically UTF-16, right? Any API call you do uses that. Even if you call get current directory A, I believe it is still converted into a wide character internally. Do not quote me on that, not quite sure. But yeah, we're just going to use that. So what we want is actually a wide character. So we have the buffer lengths. We can leave this at max path for now. And this one is... I hate that they have these type defines for like every single basic thing. So LPWSTR is really just a wchar pointer, and wchar is just a wchar t. So you can just use a wchar t. Which is what we're doing right here. So we have the input path here. If we fail to get the current directory, you can print out fail to get current working directory, right? And then we just exit the program with a failure. And if we want to see whether this worked or not, we can just print it out. I think with wprintf. Yeah. We just say, actually, wputs, right? No. Put ws. Put vc, put v. So there's puts, and surely there must be a wide version of it, but I never remember the names of it. You know what, whatever. Let's just call let's just call wide printf. Why not? Before I search too long for that name, and just put in input path right here. Current directory. Right. What? Formatting mismatch. Is it WS? No. Let's check the documentation then. So S. Oh, that should... What? Oh! The format string I'm passing in is not with wide characters, so I have to specify it as a long. So now it is a wide character one. So now this should work. Apologies. Yeah, right. So current directory, and now we see C users, micro, whatever, and we are in the GB Header Extractor folder. Cool. So now that we have that, we can start iterating through all the files in that particular folder. And let me just copy these two ROMs in here so we can actually see them when we run it from debug mode. So I also have code for this already, sort of. I'll go through it one by one though. So we have process files recursively. There's no way I'll remember all this. So that's why I like to just copy things around. So let's just do this. Right, we don't need all of that. We just have an input path. Right, and then we also have combine path. I should really put those in a header at some point so I can just import them whenever I need them. But so basically what combine path is doing is you have a result buffer that you can specify, and then you have a first chunk of a path and a second path of a chunk, and what it's then doing is it copies the first chunk into the result. It adds path separators if there are none present in the first chunk, right? And if they're none present, it adds them. Sorry, I already said that. And then it just copies the second chunk onto it. Now, there's a slight bug right now. If the second part has path separators, we have two of them. I didn't account for that, but let's not worry too much about it. Basically what this does is it's combining paths together, that's all. So, and with the Windows API that we're using, we kind of have to specify this search path. So basically we have the input path, and we add a path separator and a star onto it at the end. And then we're calling find first file. Find first file takes the search path and returns a Win32 find data structure to us. This data structure then can be enumerated with find next file to get the next file in the folder. And basically it holds, good God, where is it? Basically it gives us one file or folder from that particular search path that we have. And then you can access various things, like for example, you can access the file name, you can figure out file attributes, so is this a directory or not, and all kinds of nifty things. I just realized I probably have to rewrite combine path with wchrt, so let's just make that happen. So str length. Okay. What? Why not just str? Ah, man, those names. Jesus. Okay. So we have the source. Okay. What is the white version of this one? BCS. Okay. Yep, we have the destination. Cool, we have the source, yada yada yada. Okay, I should also copy print CRT error. Oh my lord. So print CRT error is the same as sort of as print Windows error, but well, not quite the same. It's not using the Windows API, but rather just uses p errors. So whatever the C runtime library, when it returns an error code, it sets the error number, which is called erno t or something. And with p error, you can then output, you know, whatever the C library's error message is, and combine it with your own. So I just made this little helper method right here that I can use here for CRT errors. So fail to copy path string, and then we have, I assume BCS cat. Yep. Cool. This is gonna be w chart t. Does that work? Well, I suppose we're about to find out. Or do I have to specify this long? I suppose I have to. Okay, get the length. Yep. So I'm not sure this will work, because this is now a normal string and this is a wide string, so I'll guess we'll see. Okay, that looks good to me. Okay, then we have the search path. We combine it. Right. We get our first file. If the handle is an invalid handle value, it didn't find the first file in there, so probably because the path is invalid or something like that. So we just print out an error, return false. Did I actually include stdbool? I did. Okay, cool. Now, there's a bunch of other things that we do not need to do. For example, if it is a directory, we don't do anything for now, because I do not want to deal with like recursive stuff at the moment. So I should probably remove the R. Right. And this is all from the static website generator, where I looked for specific file names, which again we do not need to do for this project. And we also do not need to specify an output path, but whoops. But we do call combine path with the file name. So because we have our input folder and the file name is just the file name, it doesn't include the whole path that we actually want. So I'm just appending the file name to the input path. We do not need all of this, which good. Let's make it to do something with the file we found, right? At the moment, what we could do, we can just print out the files. So we can say file %s, and let's do input buffer. Right. So just to recap, we're getting the first file. We're operating on the first file, checking if it is a directory or not. If it is a directory, we just ignore it. If it is not a directory, we cobble together our new input path. So basically attach the file name to the input path that we're having. And let's just do false here. And then we're printing out the file name, and then we look for the next file in the folder. And we do this as long until we iterate through all the files. If this goes wrong, it will terminate the loop, and then we can say get last error. And if the last error is normal files, or it has been set to error success, then it's not really an error, so we ignore those two circumstances. Otherwise, we print out the error that we actually encountered. Okay, why do we have a cleanup? Because we need to close the handle. Okay, fine. So result equals false, and then go to cleanup. Yeah. I call this process files, but let us call this print files for now. Failed to prepare search path, yeah. Couldn't find first file in directory, yeah. Failed to prepare input file path, sure. Failed to process all files, failed to print all files. Okay. The definition needs to go up here. Actually, I can probably put print CRT error in there as well. It's quite handy to have. Right. Okay, so now we have our current directory, and what we can do is print all the files within that directory. So we're just going to pass this needs to be a wchrt. Correct. Okay. And we pass an input path. And we do not care about the result right now, whatever. Let's just see what happens. Oh, forgot the new line, as always. Every time I do printf, I forget the new line. It's just bound to happen. Okay, cool. So as you can see, our current directory is the actual project, so GB Header Extractor, and then we just iterate through all the files and list them out. So we have the VC proj files, right? We have the main C, then we have our two ROMs, and then we have typedef.h. So that is fairly cool. And now we can extend that. Now, I'm not sure if I can extend the search path to also include the file extension. Right, so let's find that out. I mean, it's specifically looking for file names, right? So I think down here, what if I do this? Star.gb. Let's find out. There we go. Now we only get the Game Boy ROMs. Cool. Now, I'm not sure if I can include two different search parameters here. Because Game Boy Color ROMs usually have a different ending, right? I mean, I can just try it out if I just... oh my god, I hate Windows 11 so much. Like, I was looking in the list for rename, but it's now like these small little icons here, and it's just... okay. What if we have Tetris copy and we just pretend it's a Game Boy Color ROM, right? What if I do this? Okay. All right. Now we're cooking. So we can also list Game Boy Color ROMs by doing this. Okay. Now any other file extension won't work. I mean, another thing I could do is just not worry about the extension and just try and read out every single file and try to parse it as a valid header. Maybe I'll do that in the future. Who knows? Okay, so I wanna stop soon, but I kind of want to get reading the Game Boy headers into this little thing here. So let's put the reading part of the header into its own function and the printing as well. How about that? Yeah. Okay. Let's do that. So let's just say void and read Game Boy header. Let's say GB header. We have a GB header T, a pointer, which will be the header, which we want to set all the values for. We have a wchart T as the input path. Let's just say file name instead. Okay. And we just basically copy our code here. So we have reading the file, we read the buffer, set all the header stuff. There we go. I have to slightly adjust. Okay, I mean, we could add a bool here. And say return false. If we are not able to open the file, then we read from the file. If we can't read from it, we return false as well. And no longer need this. And here, what we need to do is change the dots to arrows, because we're now dealing with a pointer to a header. Cool. For the maker code, probably down here as well. Right, and then we have return true. This maker stuff is so ugly, but whatever. Okay. Right. Cool. Again, we need the definition up here to be able to use it. And then we can say so instead of print files, let's call it print headers. So instead of printing out a file here, what we're doing is we're trying to read the GameBoy header. Header, right? Get the address of header, and we have input buffer, which holds the holds the entire file name. If this fails, do we display a P error already? I think we do. Yeah, we already display a P error. So if this fails, all we do is result equals false. Actually, that happens way more than it's true, right? So go to cleanup. Go to cleanup. And actually no, go to cleanup here as well, and then we just set result equals true down here, because only if we reach this point we know everything went all right. So we can just set it to true and then return it down here. Okay, and now what we want to do is just say print GB header, right? So we have a printing function where we just pass in the header and basically print it out onto the console. So we can have that here, void GB print header. What we're taking is a GB header T, pointer of it, right, and then just print it out. And our print code will be this thing right here. Okay, again, dealing with the pointer, I could dereference it, but I'm just going to replace all the dots with an arrow. Oh dear, my stomach. Starting to get hungry. So after this, we're probably gonna stop. Okay. Let's just put it up here, even though it's not exactly needed in the main, but whatever. So we have print files. where we read the header and then print it. I just noticed something. I have not closed the file. So let's do that. Down here, what we should do is close the ROM file that we just opened, right? Sweet. Okay. Actually, I don't necessarily think we should stop if we fail to read something. So probably what I do here is only if reading it was successful, print it out, right? Otherwise, just try and continue. Because it's not the file search that failed, it's the file reading that failed. What? What do you mean not found? Okay. What is the error? Function definition for print GB header not found. But it is right here. Unresolved external symbols print files. Right. Because I called it print headers. I should also rename it, right? Okay, cool. Bam. Wait, what? What did I do? What did I do? WF open as here. Okay. WF open as. What? It's with an underscore. Oh my god, these names, I swear. Okay. We have ROM file, it's with file name. Okay, print CRT error. Failed to open file, send S. Whoop. Ah! Okay, it was just the white file open that I had to use. Okay, so cool, that works. To make it a bit more readable, let me print out the current file name. Code. Where am I? Print headers. Right. W printf. File name. %s. Don't forget the new line. We have input buffer, which is the file name. Let's print that out, and then at the end, let's just do this shebang and a double new line. Okay. Whoop, nope. Sweet. Okay. So we have still our current directory, but now, as you can see, we're actually printing out all the files in the folder. So we have Super Mario Land 2, all the header information of Super Mario Land 2 right here. We have Tetris copy for a pretend Game Boy Color ROM, where we print out all the information here, and then we have the normal Tetris Game Boy ROM, where we print out all the information here. So our folder iteration works. We're successfully iterating through all the files within a folder, printing out all the information that we care about, and just dump it into the console. So, success. So the next path, the next thing I would like to do, not today though, that's for another time, is instead of printing everything out into the console, doing comma-separated values like a CSV file, and so we can open it in Excel. It should be fairly easy. Like, instead of basically printing it onto the terminal, we're just writing it into the file in like a specific format. And that's it. At some point, also want to add some different command line arguments to refine a little bit, like so you can name the output path, or if you just want to use piping, so you don't need to specify an output folder. Also don't want to use the current directory all the time. I also want to be able to specify a specific folder on my system, for example. All this kind of stuff. But that is for next time. So yeah, that's about it. I never know how to end these things, so I'm gonna get some food now, and not sure I will be continue streaming today because my voice, my throat hurts. Let's put it this way. I think I've done as much speaking as I'm able to do today, so I'm on my limit. But maybe see you tomorrow. Thank you for watching. Bye.